Moving on to prisms and cylinders. Normally, I think in the past, you guys have probably seen to find the volume of, say, a box, you do length times width times height. Okay, and that's great, but that will only let you find the volume of a box, which would be like a rectangular prism or a square prism. Okay, so we're going to kind of generalize the equation that we use to find the volume as finding the area of the base of the figure and multiplying it by the height. Okay. And if you think about it, taking length times width times height of, say, this rectangular prism, okay, length times width does find you the area of that base, and then multiplying it by the height would be the same thing here, okay? So it's the same concept. It's this way that we're thinking about it now is you're going to be able to apply to different kinds of prisms and even cylinders now, okay? The thing to keep in mind is going to be that the height always has to be perpendicular to both bases. Okay. So when we run into, I don't know if we've got any here in these notes, like these last two examples, these are what we call oblique prisms or an oblique cylinder because they're kind of slanted off to one side. The height that we want to look at will be that perpendicular distance between the two bases. Okay, but we'll cut that bridge. Okay, so this first example here, this is a triangular prism. Okay, if you have trouble picking out the bases, just remember there are two of the exact same shape and they are parallel to each other. Okay, so here, while the triangle isn't what this prism is sitting on, the triangle is still the base because these two faces are parallel to each other and the front and the back are congruent to each other. Okay, so to find the area of a triangle, we use 1/2 base times height. Okay. The base and height of this of the triangle are 12 and 10. Okay. So the area of our base is 60 square centimeters. All right. Now when we go to look at the height, we need to ask ourselves, how far apart are those two triangular bases? And in this instance, they are 11 centimeters apart. So to find that volume, we're going to take the area of our base times our height to get 660 square centimeters. Okay. Example 2 here, we have a cylinder. Okay. Cylinders, remember, their bases are always circles. Okay, and to find the area of a circle, we use pi r squared. Okay, in this picture, 9 is actually our diameter. And so if 9 is our diameter, our radius is 4.5. Okay, so sorry about that. The area of our base, we're going to take pi times 4.5 squared. For an area of 20.25 pi. Okay. The height, okay, I know this cylinder looks like right now that it's 9 inches tall, but remember that height is the distance between the bases. So our height here is 5 inches. To find that volume, we're going to take the area of the base times the height And the exact answer for this cylinder would be 101¼ pi. Okay, don't forget that pi needs to be included. Okay, so that's our exact answer. But if we want to have an approximate answer, it's about 318 9/100 inches, and actually cubed. Sorry about that. Okay. Example 3, I've got a pentagonal prism. Okay, the base is a pentagon. Because the bases are pentagons. Okay. And for any regular polygon, we use that 1/2 ASN. Okay, the apothem of this pentagon is 3.4. The side length is 5, and there are 5 sides. And so the area of one of these bases is 42.5 square millimeters. Okay. For the height, again, ask yourself how far apart are those bases? In this case, they are 8 millimeters apart. Okay, and to find the volume, we take the area of the base times the height. And that gives us 340 cubic millimeters. Okay. Example 4, we've got another cylinder. So the area of that base pi times the radius squared is 16 pi. Okay. The height is 13 inches. Okay, those two circular bases are 13 inches apart. And to find the volume, we take the area of the base that we found to be 16 pi times 13. So the exact answer would be 208 pi inches cubed. But if we wanted to write that as an approximate answer, when we multiply pi out, we get 653.45, not 54. Ooh. Sorry about that. Okay. Now the last two examples here are our oblique cylinders and oblique prisms, okay? In number 5, we've got a hexagonal prism. And this one is nice. It actually gave us the area of the base. Okay, so we don't have to do any calculating for the area of the base. It tells me, hey, area of the base is 17.3. Okay. Our height, remember, we still want to know how far apart those bases are. Okay, it being a little slanted doesn't change the fact that our height is still that perpendicular distance. Okay, so our height here is 6.4. And to find the volume, we take the area of the base, which was given to us, times the height. And so 17.3 times 6.4 is 110.72 cubic centimeters. Okay. And last but not least, we've got an oblique cylinder. Okay, so finding the area of the base is not going to be any different than the previous two cylinders. Our radius is 4. So just like example number 4, the area of our base is 16 pi. Okay. Now our height is going to be this perpendicular distance here. Okay, now looking at this picture, we don't have that distance, but we do have this right triangle here that's created. Okay, so I'm gonna go ahead and do the Pythagorean theorem. 9 squared plus what squared gives me 15 squared. Okay, we go through that, we find that our height is 12. Okay, so to find the volume, we take the area of our base times our height for an exact answer of 192 pi. Okay, or an approximate answer of 603 and 19 hundredths. Okay,